client-side JavaScript for Ruby programmers. What do you need to know now that you know Ruby? This is going to go through the basics of JavaScript pretty quickly. But like Ruby, JavaScript is interpreted. It's dynamically typed. The basic structure in JavaScript is an object, which looks very similar to a Ruby hash. It uses curly braces. The syntax, we can say let movie or var movie to declare this thing. We have the keys are called either properties or slots in JavaScript, but properties and slots are sort of the most common words. They can be quoted. They don't have to be if it's a valid variable name, but you'll see both versions of that. And typically what we'll be doing today is using the browser console to debug interactively and explore how we might write, update content with JavaScript. The browser console is the sort of standard interface for interacting with JavaScript, to debug and explore a website. Outside of the browser, there are other JavaScript runtime environments, but of course, what we're going to be focusing on is the browser. Things that you should sort of just know in terms of basics. Again, no need to memorize these, but helpful to get familiar with. Statements in JavaScript end with semicolons, but they are optional. If you leave them off, JavaScript will do the right thing. More often than not, you can totally get away with it. There's very few cases in which you absolutely need semicolons. JavaScript does not have integers and floats. It has one number type called number, which unifies integers, floats, and big integers. So the max value is something like 2 to the 1024, which is great for doing sort of a lot of basic math and not having to worry about it. Like Ruby, JavaScript has string interpolation, which is a really handy feature. JavaScript's version of string interpolation uses backticks, whereas Ruby's is double quotes. And to note a JavaScript expression, you use $signs and curly braces instead of a hash and curly braces. But fundamentally, sort of similar ideas. Like Ruby, JavaScript has regexes built in. They follow a similar syntax. You can just use slashes as a regular expression, literal, right, in a program. And we're not going to probably explore this today or this week, but JavaScript has support for things like modules and imports. This is in the space of newer features that are useful, but browsers don't fully support. So when you develop an application, you might write code that uses import statements and have a compilation step to resolve those into something that the browser typically can run without any conflicts. But fundamentally, modern JavaScript, even though it didn't start off this way, looks a lot like any other programming language. There's libraries, it has a pretty common set of types, it has string interpolation, and so on. Variable scope in JavaScript is fairly standard with a couple exceptions. So there are three common ways to declare a variable in JavaScript. The two most common are var and let, which declare a variable in the current scope. If you leave off a variable declaration, the variable is global by default. And this is one of the places where JavaScript perhaps differs a little bit from most other languages, is that by default, variables are global, and we're going to use declarations like var and let to restrict the scope of a variable. There are minor differences between the two, but you don't need to know them. You could use either interchangeably for the most part. JavaScript does have constants, so if you need to declare a constant, you can use the keyword const. And same deal as most programming languages. If an integer or a string is constant, you can't change it. But if it's an array or an object, some mutable data type, that name will be declared constant, but you can change the innards of mutable data type. So this, again, follows pretty much the same type of structure as most other dynamic languages. Importantly, functions are first-class objects in JavaScript, and they are closures, which means if you think back to your early days of learning programming, they are full lambdas. You can capture that environment and use the variables that are in their environment. It is extremely common to pass functions to functions in JavaScript, and we'll see some examples today of that. And it's also really common to use collections of functions that are properties of an object to sort of build a module or a library of sorts to organize our code. So in the browser, when everything is global, JavaScript doesn't have the same sort of common functionality like Ruby does for explicitly declaring a module or a mixin or something like that. But similar tools and practices exist. And because JavaScript is dynamic, we can modify things when we need. The best practice is to basically make our own modules by using objects as a collection of related functions and information about a particular task. So you might make a movie object or a Rotten Potatoes object in JavaScript to group all this functionality together. And we'll definitely see some examples. So this is what a standard sort of object looks like in JavaScript that you might see. You might declare something as a global variable which says, my app, whatever the name is, stuff the functionality in there. Essentially, this is just a JavaScript object. When we say object, we mean just the bare minimum of mapping key to value, which can have any number of properties. So typically we'll name functions. You might have, something like count the movies on a page or, request new data from a server, but anything that you want, you can stuff them in there. In JavaScript, if we declare an object, we use the colon, similar to Ruby, to separate keys from values. And similar to other languages, we can just say my object.property is equal to something, and that will assign that property to that value. There is square bracket notation, similar to Ruby and Python as well, but objects are sort of the core interface in JavaScript. So in a browser, scoping becomes important. And this is one of the things that is a little bit tricky in JavaScript, is the default scope of the JavaScript console in the browser is sort of the global scope, which is global to that current window of your application. It is not global across all of your tabs or browser instances. But when we say global, we mean the currently running page gets its own sort of global scope. In JavaScript, similar to Java, the keyword this refers to the global object. And in an object-oriented sense, it will refer to a particular instance of an object. But by default, that is the window property in a browser. So in a browser console, you can say something like this.body, and you'll get the body element of the window object. But typically, what you'll see is in a browser, the thing that's called window is sort of the global object that contains all of the information about your current browser session. And this is scoped in a browser by HTML page. So when we load a JavaScript file in our Ruby app, whatever code runs in that file will run in the context of that current page. When we open a new page or we navigate away or open a new tab, we'll get a new version, a new sort of global scope for the runtime of that page. And that scope exists basically until that app or that web page is closed. So objects that are global in JavaScript are there until that tab closes. They cannot interact with or see data about other tabs for good privacy reasons, but you do have a lot of functionality that will live around. In JavaScript, or I should say in Ruby, when we load JavaScript files, we typically use a structure like JavaScript include tag. There are other versions in Rails, JavaScript pack tag for certain applications, but essentially this is a Rails HTML function that generates the proper script tags that load the file. In particular, Rails does a lot of nice tools such that when you deploy your application, this file is guaranteed to be the most current version. It handles things like browser caches and all sorts of, potentially annoying stuff to deal with to make sure that your JavaScript loads correctly on the page every single time. In Rails, there's the asset pipeline amongst other sort of parts of the process that build this file. And for the most part, you can use it pretty transparently. You don't need to know the details of exactly how Rails compiles the file. But if you need to change those, the functionality is there. The best practice is to separate JavaScript components into multiple files and to load things when you need them. The Rails asset pipeline helps with that. There's a bunch of JavaScript native tools that do similar things. But essentially, you want to think about when we work on code, we have multiple models, multiple controllers. You want to mirror some of that structure in your JavaScript because it turns out that, trying to debug 1,000 lines of code is an order of magnitude easier than debugging 10,000 lines of code. And so separating JavaScript into multiple files is a really good practice. And Rails has the tools for you to make sure that that is performant and efficient and so on. So JavaScript has a bad rap, but there's a lot of really simple guidelines that you can use for following and writing good JavaScript. So the guidelines from the book in chapter 2, SOFA work. The other best practice is keeping JavaScript code separate from your HTML. If you're writing views where we say minimize the Ruby code in your views, minimize the direct JavaScript code that is embedded in HTML as well. Put it in a file, that can be tested, that has a function which has a name which you can call. Similarly to when we learned test-driven development, you can do red-green refactoring with Jasmine. That'll be coming up in the next couple modules. There's a really good book called JavaScript, The Good Parts. It's sort of old at this point in terms of the specific bits of JavaScript that it uses, but it really just gives you a sense for what does writing clean JavaScript look like, despite the fact that HTML is a very declarative sort of language for building a web application. You can write very nice and very functionally oriented JavaScript that interacts with the web page. In Ruby, you might have used tools like Rubocop or other linters that assess the quality of your code. Those exist for JavaScript as well. And in some of the later chips, you'll see some of those. And tools like CodeClimate that we'll use in later chips also support JavaScript. So relying on tooling to enhance catching bugs, providing recommendations is super useful.